We're just off a highway in southwestern Minnesota because here you'll find this bold sign and a rock that looks like a swirling galaxy trapped in stone. This isn't just any roadside boulder. This is Morton Gneiss, a chunk of the Earth's history that the sign says is over 3.5 billion years old. That's only about 1 billion years younger than the planet itself. So is this truly the oldest rock? And what secrets can this geological giant tell us about our planet? To find out, I talked to Nowariak, a geologist or bedrock mapper with the Minnesota Geological Survey.
The Gneisses down in southwest Minnesota do hold a kind of a special place in my heart.
It doesn't get much more Minnesota nice than that. Okay, let's rewind several billion years to when these rocks first appeared.
It's really hard to know originally how it formed, but we do know that it was some sort of melted crust.
The Earth's crust is like a giant puzzle, broken into pieces called plates. The plates move, collide, and pull apart, forming continents. This is known as plate tectonics. However,
when we're thinking of the Morton Gneiss when it was formed, we aren't really sure as geologists if plate tectonics was working in the same way.
Fast forward 1 billion years, and things get dramatic. Two pieces of the Earth's crust, one carrying our Morton Gneiss, collided in the region known as the Superior Province, which is a giant chunk of the Earth's crust that has been preserved and is older than everything else around it.
Then it was likely part of a supercontinent in itself.
This immense pressure and heat from the collision caused the granite to partially melt again, creating the pink streaks we see in Morton Gneiss today.
You see how magma is injected within a rock as it's actively melting or deforming.
Around 2.1 billion years ago, the supercontinent starts to break apart. The Morton Gneiss becomes part of the core of what is now the North American plate. Over millions of years, Morton Gneiss found itself buried under layers of sediment and rock. Then, the ice ages arrived. Around 12,000 years ago, the glaciers began to melt, forming a massive glacial lake called Lake Agassiz.
And at some point, as that glacier that was damming it up started to retreat, that sent all that water flowing down through what is now the Minnesota River Valley.
This powerful river, a mile or so wide, acted like a giant excavator, ripping through layers of glacial deposits, finally exposing the ancient Morton Gneiss beneath. So the Minnesota River Valley became the key to preserving and revealing one of the Earth's oldest rocks.
They're just kind of little mounds sticking up. They're not big mountains. They're not jagged outcrops or anything like that. The elevation that we see today has been more or less the elevation since the formation of that North American plate.
This ancient rock isn't just an enduring wonder. It's also a striking and durable building stone. Polish in Morton Gneiss, and it turns into a pocket galaxy.
They call it rainbow stone. You know, it's hard to take your eyes off of that swirly nature of it.
Because of its unique properties, Morton Gneiss has been quarried for over a century and is used in buildings across the United States. And just a few miles away from the sign, the town of Morton, Minnesota, takes its namesake rock very seriously. Morton Gneiss was first quarried there in the 1880s, and you'll find Morton Gneiss displayed on their welcome sign and on buildings around town, like this old school. It's a constant reminder of this town's unique connection to Earth's deep history. So next time you're admiring a grand building with beautiful pink granite, you might just be witnessing a piece of the Earth's 3.5 billion year old history. So we know Morton Gneiss is old, but just how old are we talking? And how do scientists figure that out? It comes down to atomic clocks inside the rocks, radioactive elements called isotopes. These isotopes naturally decay over time at a predictable rate known as a half-life. By measuring how much of the original isotope is left and comparing it with what's already decayed, researchers can figure out when the rock first formed. Now, the world's oldest rock sign went up in 1975. Back then, researchers used rubidium, which decays to strontium, and samarium, which decays to neodymium, to date the rocks. This was pioneering work at the time, led by Samuel Goldich at the University of Minnesota.
We still use those same concepts, but we now use uranium, thorium, lead systems. And moreover, we don't use the whole rocks. We use single crystals, these zircon crystals.
So what do these zircons tell us about the Morton Gneiss in southwestern Minnesota?
There's quite a good population of those 3.5 billion year old zircons within that rock. We think the primary rock formed 3.5 billion years ago.
So not quite as old as the sign says, But are they the oldest rocks in the world?
It did hold the title for oldest dated rock for a while. There have been now a couple of different rocks that are older, namely the Acastia Gneiss in Northwest Territories. That's believed to have formed 4 billion years ago, plus minus a few million years. Beyond that, we have found even older zircons. They've been separated from their primary host rock. So you could say the oldest rock that we know of is the Acastia Gneiss, and the oldest crystals that we know of are from the Jack Hills in Western Australia.
So back to the sign, it's not exactly accurate anymore. Even in the US, there are 2 other contenders for the country's oldest. These are rocks found in Wyoming and Michigan. All of these ancient rocks were probably once part of the same early crust that formed when our planet was still young. The sign, though, stands as a testament to how science evolves and to what was the best research available at the time. That said, while Morton Gneiss might not be the oldest rock, it's certainly one of the most accessible ancient rocks on Earth. You don't have to trek to the tundra or a remote mountain range to see it. It's sitting off a highway in Minnesota for anyone who wants to walk up and touch a piece of the Earth's deep history. Thanks for watching, and be sure to subscribe for more videos.